Okay, so this is going to be a short video on how to read those solubility graphs. Okay, so when we're talking about solubility, we're talking about how easy it is for a solute to dissolve in a solvent. All right, so and some things are more soluble than others. For instance, looking at this table, sugar is a whole lot more soluble than table salt. So you could dissolve more sugar in the same amount of water at the same temperature as you could for table salt, right? So you often see solubilities listed in tables along with the temperature, and that'll tell you exactly how much can dissolve in that amount of water, right, at that temperature. Okay, and then you have these graphs, and these graphs show you how much solute can dissolve at a given temperature. Okay, and for solids, more solids can dissolve as the temperature increases. For gases, it's opposite. Gases, less gas can dissolve the warmer the temperature. So if you remember from the Diet Coke and Mentos experiment, as we heated it up, the carbon dioxide wanted to get out more, so there's a larger explosion because it couldn't dissolve as easily as at the colder temperature. Right. So there's three types of solutions. Okay, there's unsaturated, saturated, and supersaturated. Right. So an unsaturated solution could hold more solute. It's not that much is dissolved at the current time at that temperature. So think of it like buses or trains, and think of an unsaturated solution as, here are these people on a train, but a lot more could fit in that train. So it's unsaturated. When the train is completely full and it can't dissolve anymore, it's dissolving as much as it possibly could. That's called a saturated solution. Okay, and a supersaturated is when more is dissolved in there than normally would be at that temperature. Okay, and these are kind of like special solutions. You have to make them just so they're not very stable, but they have managed to dissolve more than would normally be dissolved at that temperature. Okay, so supersaturated. All right, that's how we make our rock candy, and a lot of crystals form that way through supersaturated solutions. Okay, so reading these solubility curves. All right, so what the curve shows is a saturated solution at that temperature. So anywhere along the curve is the saturated amount, how much can dissolve at that temperature, right? Let's see, so here's an example here. So for example, at 40 degrees Celsius, right, so look at the bottom, there's your temperatures at the bottom. Carry that up to the point for when we're looking at sodium chlorate, which is NaClO3. Okay, so follow that up to the curved line and follow that over to the solubility. The solubility on the y-axis tells you how much can be dissolved. All right, and so at 40 degrees Celsius, let's see, 130 grams of sodium chlorate could be dissolved in 100 grams of water, right? And so you know it's 100 grams of water because it will say that over on the y-axis under there. Okay, so any point along any of the curved line is a saturated solution, right? Okay, now if a solution contains less, then the point would be below that curved line. For example, at 80 degrees Celsius, so find the 80 degrees along the bottom, and if we're looking at 120 grams of potassium nitrate, the KNO3. So if you look to see where that KNO3 line is, and look to see where the point meets for the 80 degrees and the 120 grams, that is below the line for the sodium, for the potassium nitrate, KNO3. Okay, so that would be an unsaturated solution. So if the point is under the line, it's unsaturated. All right, if it contains more than the solvent can hold at that temperature, it would be supersaturated. So if the point's above the line, then it's going to be supersaturated. All right, so for example, here at 100 degrees Celsius, so find the 100 degrees at the bottom of the graph and look over to the y-axis for the 160 grams. Now we're looking for potassium bromide, KBr. So we can see the curve for the KBr and see where the point is. And it's above the line. It's above the KBr curve line. Okay, so that would be a supersaturated solution. So you'll see questions where it's asking what type of solution is this? Is it unsaturated, saturated, or supersaturated? And all you do is find the point, match up the point from the temperature and the amount dissolved, and see if that point is below the line, it's unsaturated, on the line, saturated, above the line, supersaturated. Okay. You also need to be able to read a table and tell whether a solution would be saturated, supersaturated, or unsaturated. Okay, so the table gives you the saturated amount, right? So if any amount is below that amount, then it's unsaturated. If the amount given is over that amount in the table, then it's supersaturated. Okay, so to make it for example, okay, so for this one, we're looking for an unsaturated solution. So for baking soda, 9.6 can be dissolved at 20 degrees Celsius. But if you had only 8.0 grams, 8 grams, it'd be unsaturated. Okay, so for this one, a supersaturated solution. Again, for baking soda, 9.6 can be dissolved, but if you have 11 grams, it'd be supersaturated. Okay, so most of the time, the tables will be more complex. It'll contain many solutes and several different temperatures. Okay, and so that can get confusing, but it's real easy to work with this if you just follow a simple thing. Find where the temperature is. Put a U on the left-hand side for unsaturated, meaning that if any amount is below that number, then it would be an unsaturated solution. And put an S to the right around each temperature, just like I have here, US, US, US. All right, so here's an example here. So what type of solution is formed when 30 grams of potassium nitrate is dissolved at 20 degrees Celsius? All right, so we're going to find the 20 degrees Celsius. We're going to find potassium nitrate, down fourth one down, and it is saying 30 grams. So we look at the 20 degrees Celsius for potassium nitrate, and normally 31.6 is a saturated solution. 30 grams is less, and so it's going to be unsaturated. Okay? All right, and here we're going to have a supersaturated solution. So we're looking at potassium chloride, third one down, and we're looking for 40 grams at 20 degrees Celsius. All right, well, 34 grams is the saturated solution, and 40 grams is more than that, so it falls to the right of that number, so it's supersaturated. Okay, so if you remember those tricks with the US, if you try that, it'll make this table a lot less complicated than how it originally begins. All right, so hopefully that helps.